And let me go ahead and share my screen. Okay, so this is your class's Canvas page that I'm sharing right now. And this is what it looks like. It has the syllabus. Oh, so one thing that I have not shared with the whole class and which I won't be doing via email is that the textbook that you have, um, you know, it's also on your Canvas page. So you can click on this link and find the textbook, okay? And then you have the introduction slide. So what we'll be doing first is going over the syllabus. If you go here, click on the syllabus. So this is CE 321, Fundamentals of Transportation Engineering. And it's a required introductory class on various modes of urban and intercity transportation and science of transportation planning and design and operations. And then it builds on a lot of knowledge that you may have gained in physics, in math, in statistics. So some of those material is going to be sort of prerequisite for that. And this class will be meeting 9:40 to 11 starting next week in building 10, room 231. So that's our class location. That's where we'll be typically meeting. And then my office is in building 13, room 212. And my contact info, I have my phone number and my email there. But the email is the best way to reach me. In case you need to reach me, just make sure that you send me an email. And then my office hours starting week 2, Monday 11 to noon, and Tuesday, Thursday 8:10 to 9:30. So make use of those office hours. Office hours are a great way to interact. I mean, there is a lot of discussion, that a lot of things that you may not be, maybe you may not feel comfortable asking in front of the whole class, although you should. There's no reason you should hesitate asking any questions in the class, but sometimes it happens. And there could be something else that you need help with, right? So always make use of these office hours. And if you cannot make these office hours, like for example, if you have a class or something right at that time, you're welcome to use the Calendly link that I provided to schedule a time to meet with me. You can meet with me virtually, or you can meet with me in person. Either way, I welcome those interactions. So please be sure to try and interact, because I think what happens is that this is one of the resources you have available, right? I mean, you're paying the fees, and there is a lot you can get out of these faculty interactions, and you should always try to make use of these. So just, even if you just want to come by and say hello, I think that's fine. Like, I don't mind folks showing up for office hours. If you have availability, if you want to just come by for no reason, that's perfectly welcome as well. So and obviously if you have questions, you're welcome to ask any questions during office hours as well. And the other thing I would say is that, your question may be related to a class. It may be related to, something you're working on at your internship or whatever, or it could be, maybe you're having some trouble, which you think maybe you're not sure if I can help you or not, but you won't know until you ask. And there may be things that I cannot help you with, and which is fine, but maybe there are resources at Cal Poly that I could introduce you to, that could help you, right? So there is a lot of resources that Cal Poly offers to support our students, and you may or may not be familiar with some of them, but I'm pretty sure I can hook you up with those resources as needed. So anytime, even if you're not sure if I can help you, just try me, right? So I think that's usually a good thing to do, because I've been here. I joined Cal Poly in fall of 2008, and I've learned a lot of things about Cal Poly. And that's not to say that I don't learn new things about Cal Poly every quarter. I do, but there is a lot that I can share with you. So just reach out to me if there is anything, even if you think remotely that I could potentially help you with anything at all. I'm happy to try and do that. All right. So first things about this class. Getting prepared. So always check Canvas for reading assignments, lecture notes, and homework problems. I know if you need permission numbers, you're probably not on Canvas just yet, and that's fine. One thing I could do is I could probably send you an invite to add you to the classes Canvas page. I'll look into doing that. I'm not sure if I could do that for folks who are on the waiting list, But in lieu of that, at least what I've done is I've emailed the resources that are on Canvas right now, except for the textbook, which I cannot email. But what I'll trying to do is like I'll see if I can make everybody who's on the waiting list and give access to this course to them, and then we can look at it afterwards. Okay. So the required textbook for this course is Fricker and Whitford, Fundamentals of Transportation Engineering. And I have just, let me see. I'm going to have to stop share for just 1 second here. Okay. So just make sure that you, and then there will be like, other things that may be available to you, the latest versions of, okay. And then there will be other resources. For example, this textbook is a little bit older. And because it being older, there are some resources that have been updated since then. All right. So there is AASHTO Green Book. That's a new version of that. Federal MUTCD. There's a new version of that. The highway capacity manual. There is a new version of that. So all of those things are new. There are newer versions of that than the information in your textbook. So all of those resources, I will be providing the relevant sections of those resources to you for this class free of cost again. So you don't have to spend any money for the textbook on this class. But there will be, there are some things that I'm going to ask you to read from the textbook. So those are the fundamentals. But if there is some design manuals and things like that, then those things I will make available separately. And I'll specifically point out that, hey, do not refer to these sections of the textbook for this part of the course, because that section of the textbook is referring to the referencing the old material that's no longer applicable. Okay. So just be sure of your reading assignments that are going to be coming from the book versus the reading assignment that I'm going to clearly lay out and say, hey, do not read this stuff from the book because that's the older version. So just make sure you're clear on that. All right. So any questions about the resources for this class, or how the class will, how you contact me and things like that? I'm happy to take those questions if you have any. You can either unmute yourself and talk, or you can type the question in chat for everybody to see. But if you don't feel comfortable, you can just chat the question to me specifically. I think I found that sometimes is more friendly way of students being able to ask the question. So I'm perfectly fine with that. So I'll take maybe give it a couple of minutes in case folks have any questions so far. You can also raise your hand. Okay, seeing no questions. All right, no questions so far. Okay, we'll move on. Okay. So we'll talk about the proposed topics of study, and for each topic, I have what I call the learning objectives, so what you should be able to do after we have finished that chapter. So for example, once we have finished with chapter 1, highway transportation basics, you should be able to define transportation engineering, identify the legs of the transportation system, and ask some questions necessary to specify the system, and then look at some performance measures and examine what the performance measure should be, right? And then we're going to be, digging deep into these different legs of the system in future chapters of the class. We'll learn some technical material, but from the introductory chapter, these are my learning objectives. I want to be able to make sure that you can answer these questions, or you can do these things once we have finished the first chapter. Okay, and then same thing. I have the second chapter, or chapter 4 rather, and that's basically on modeling demand. And then I have similarly some learning objectives there. And then you have chapter 5, engineering economics. There are some learning objectives there. And then sustainability. So I have some learning objectives for chapter 13 as well. So this class will be divided into 3 different modules. So there is module number 1, right? So there is then module number 2, And then the last one is module number 3. And each of these modules, you're going to take a test on these, and there will be like a problem set that will work on, that will be graded for you for each of these problem sets, right? So classes, you can think of this class as sort of 3 mini classes that last sort of 1/3 of the quarter each. And the idea is like you become familiar. In the first module, we work on planning of the system and thinking about what might happen in the future, right? So maybe trying to forecast the future, trying to analyze some alternatives that you may build in the future, and then making sure that whatever we build is sustainable for the long term and not destroy ability of the future generations. So module 1 that we are dealing with is going to be about the future, about what are we going to build, where should we build it, and things of that nature. So trying to come up with the demand for the system. Module 2 is also sort of about design. It's about design of the system. So once you've planned what you're going to put, like where the road is going to go, so module 2 is actually putting together the infrastructure, actually putting together the design of the roadway or the roadway network or a segment of the highway and things like that. So that's kind of what we're going to do in module 2. So this is where you learn about, you learn about highway safety. You learn about actually just doing the design work. Uh, uh, horizontal and vertical curve. How do you make sure that you are providing curvature on the road that's safe to travel on? So this is, actual design. So this will also relate to your CE 322 lab that you may be working on, at the same time or maybe a little bit later. So we want to make sure that you have done the design work in the class before you do the AutoCAD lab in the lab. So in CE 322, you may be doing the design work as well at some point, and that will relate to, for example, chapter 7. Okay. So, and then we'll also look at the pavement design, and you may be doing a couple of labs on pavement engineering as well. And then I think the main thing that we learn in pavement is kind of figuring out what type of, truck loads we should be designing for, and then, kind of being able to estimate what we call the equivalent single axle load. So how much load is the pavement going to be subjected to? And based on that, in the future classes, you can learn about what should be the thickness, what type of pavement should be put in there, how do we design that pavement? So all of that can come later. But in this class, you'll be figuring out what are the key design element, the equivalent single axle load. So estimating that. So kind of module 2 as a whole, chapter 6, 7, and 9 deals with more sort of immediate design of the system, like something that you're going to design, something you're going to build, in the near future. How do we design that? So the first module is about long-term future. Module 2 is about what we are going to build. How do we design precisely what we're going to build? So coming up with specifications of what we are about to build in terms of pavement, but then also in terms of the roadway design, horizontal and vertical curve, the slopes and things like that. So we'll be dealing with those. And then module 3 is going to be about analyzing what is, right? So in module 3, we'll learn about how do we measure how the traffic is flowing? What are different traffic measures that we use? How do we collect that data? And once we collect that data, how do we analyze it? And kind of thinking about how do we grade a roadway performance, right? So if there is a freeway that's operating, the peak hour conditions are given to you. How do we analyze that peak hour condition for our purposes and say, what level of operations we are at, right? So that's the kind of thing that we'll be dealing with module 3. And again, these things might feel like almost the 3 different classes. And you can, they in some ways they are, because what happens is that for each chapter that I'm going to go through, I'm going to put a future tech elective course where you can learn more about that particular topic. You can dig deep into that topic in that class. So for example, when I talk about the pavement stuff, we'll be talking about CE 429, right? So I'll say that if you're interested in this stuff, go take CE 429. When I'm talking about benefit cost analysis. So I'll mention CE 528 because that's transportation economics and analysis. So if you want to dig deeper into benefit cost analysis, that's the class you should take. If I'm talking about crash rate, collision rate, I'm going to talk about CE 526. That's the class you should take. When I'm talking about traffic flow theory, I'm going to say, okay, yeah, you should take traffic engineering CE 421 and CE 529, for example. That's modeling and simulation. And same thing with capacity analysis. So every module, every chapter that we go through, you will see a future Cal Poly class number that's going to be attached to it, where you can dig deep into that subject area. Now understand that this is a required class. So some of you, for some of you, this may be the only transportation class you take, which is fine, right? So I mean, I'm not gonna, although I love transportation and we would love to see more people doing transportation, but that's not something, but I understand that that's not something you're interested in. But I think because we we look at the material in this class in a very shallow way. So we cover a lot of breadth within transportation, but we don't go deep into any of the material. So I feel like it's my duty to point out that where you can dig deep into a subject area, because what I'm going to tell you is that you will hear this term that, okay, in this class, we are going to keep the stuff simple. And this is for the benefit of folks for whom this might be the only transportation class, because I need to make sure that they have some knowledge of the broader transportation areas, but we're not digging so deep into, if you're never going to do transportation ever again, you don't have to go dig that deep, right? So that's kind of something that's going to come up, the future classes where you can learn more about and how we are keeping things simple in this class. So the scope is the work or the depth is going to be somewhat limited on all the topics that we cover. Okay, any questions about, sort of the material that we're going to be covering in this class, these topic areas? Okay, so one thing I'm interested in at this point is just kind of knowing about, if you can raise your hand virtually and tell me, and I can probably, okay, so I see something in the chat. Okay, C320 required to be taken concurrently with this class? Probably not. I think C320, I'm not exactly sure. So that's a good question. I should know because I've been here 17 years. So, and I probably had some say in that decision whenever that decision was made, whether C322 should be required. But off the top of my head, I can't remember. I think you do have to take 321 before you take 322. So it could be either concurrent or before, but it can't be after, is my understanding. You cannot take CE 321 after CE 322. I think that's my understanding. So I hope it answered. I hope that answers your question. Okay, so I've got another question about what weeks do we expect the tests to be given? Okay, so that's a good question. So I'm thinking like maybe week 5, week 8. So it could be end of week 4 or week 5 or beginning of week 5. So that will be our first test. Week 8 would be our second test, end of week 8 or week 9. And then our last test, depending upon how well we are doing with the material, what speed we are going, the last test could be either during dead week or during the finals week. But you guys need to be planning to be here during the finals week. So even though, it's possible that we might actually end up doing the test on dead week, and I'll come to that, like, in terms of tests. But that's just the idea like I have right now. But Josh, you had asked about like whether it's concurrent or not. Just make sure that you verify from the catalog, right? So I don't take my word for it. I could be wrong. So just make sure that you know you verify it from the catalog. But I think there are two different class numbers because I think you can in fact take them in different quarters, is my understanding. But just don't take my word for it. Just verify from the catalog. All right, great. Any other questions? Again, there are no bad questions. Only bad questions are the ones you don't ask. So feel free to ask away either by unmuting yourself or via chat. Happy to answer any questions you may have. Right. It's like no questions so far. All right. So what we'll do is look, we'll go again. We'll All right. So, now we can get to the tests and the grading and so one thing that I also grade you on is participation. And participation, so you will get a lot of, you'll get your quizzes, your tests, and so forth for this class. But I'm also looking for your participation in terms of timely submission of the work. If I assign you a quiz or something, make sure that taking the quiz on time. If I assign you a survey, you're taking that survey on time. Just make sure that you guys are doing that. Um, um, so so yeah, please go ahead and make sure that you are actively participating in the class as we're going forward. So showing up for all the classes. If you're absent, let me know via email, so we can make sure that you are still keeping up to date and things like that. So participation also has like 10% of the grade, and you can just get those 10% by just timely submitting your work, coming up, showing up for the class, and just participating in any surveys and things like that that I give you. Okay, so one of the other questions I've gotten in the chat is, will we explore other form of transportation like aviation in this course? Unfortunately not. There is a lab that we do in CE 222, I believe, and that's the only aviation exposure you get if you're not going to do transportation. We do have a technical elective in aviation that you should be taking if you're interested in aviation, and it's a very interesting and exciting class, and it's taught by a person who's a certified pilot himself. So it's a very, very good class. And if I have the time, if I had the time and inclination, I mean, if I had the time, I'm definitely inclined to take that class myself. I just haven't not gotten around to it. But it's taught by Dave Hutton. It's a very good class, typically offered in the winter quarter. So yeah, if you're interested, you should definitely take that class, that tech elective. I believe it's CE 525. Even though it's a graduate class, undergraduate student can still take it. So you should consider taking that if you're interested in aviation. So that's the other question. So we will not, even if we will not be covering aviation in any kind of meaningful way in this class, you will have opportunity to take a full tech elective if you're interested in aviation. All right. Any other questions so far? Okay. So let's get to the grading piece. So you will have the homework and short quizzes, about 30% of your grade. Your tests will be 60% of the grade. So every test will be 20% of the grade. Now, there will be a final exam. Okay, there will be a final exam at the end of the quarter. And that final exam is actually optional. And that's something that I do that can be a little bit confusing, but hopefully not once I explain it. The way the final is going to work is that if you think, so final is going to be cumulative, so based on all material that we cover throughout the quarter. And if you do well in test 1, test 2, and test 3, you need not take the final. If you feel like you've done enough and you will not improve your test average, the 3 test average in the final by taking the final, then you can just skip taking the final, and no harm, no foul. There's like your midterm grade, 20, 20, 20% each for each of the 3 midterm tests will become your test grade. That will be sort of 60% of your grade total. However, maybe you missed it final, or you missed a test, or you did really, really poorly on 1 or 2 of the tests, right? But you think you have done, you can actually improve on that because you were not feeling that great that test. And it's just a test, right? 1 hour, 20-minute test, you can mess up sometime. And if you feel like you can improve on the test, you can take the final. But the trick is you have to take the cumulative final, and it will replace all 3 of your midterm grades, not just the worst of your midterm. Okay, right? So it's not going to replace the whole midterm grades. I mean, it's going to replace the whole midterm grade, not just any one of the ones that not just the one that you screwed up. Okay, so that's the trick. So if you feel you can, once you have seen your midterm score in 3 tests, you can look at it. Let's say your average in the 3 midterms is 85. And you feel like if you were to take a cumulative test, you can do better than 85, you go take that test, right? Now, the good news is that let's say you thought you could do well, but you didn't do actually well. So you took the final and you only scored 80 out of 100 and your midterm average was 85. So then your score still remains at 85. I don't penalize you for just taking the final and doing badly in it, right? Because I know it's a cumulative final. There might be material that we covered long ago. So there could be reasons where, it's not, necessarily fair to penalize you. So basically, the final exam could be a makeup for their test average, and it just substitutes your midterm scores. So it just substitutes your midterm scores. Okay? Any questions about how the final is going to go? And again, the date for these tests, week 4 or 5 for test 1, week 8 or 9 for test 2, and week 10 or the finals week for week test 3. If we do end up, and I don't ideally like to do that, but if we do end up doing the final and the test 3 on the same day, you'll take the test 3 in the start of the final exam period, and then last 2 hours of the final, or last 100 minutes of the final exam scheduled would be reserved for the cumulative test. Okay. Questions about this? Any questions? So I'm not seeing any questions. That's great. So we can move on. So this class is not going to be. So one thing I tell you is like, for transportation classes, transportation is a subject area which actually is like a little bit less complicated in some ways than other fields of civil engineering in the school. But in practice, it's much more complicated, right? So the good news is because this is a sort of a breadth class, we're not going to dig too much deeper into it. You may think this is one of the easier class, right? So you may think this is something, and you will see it. This is, in fact, in terms of tests and everything, you might find the content will be a little bit less challenging than some of the other classes in civil engineering. You might find that. So, and especially because this is a required class for everybody, and not all of you are going to practice transportation, which is where things get much more complicated because we have human users in transportation system, and they can complicate things for us as designers of the system. So what you will find is that it's a little bit less challenging content because it's deep and not, I mean, it's wide, but it's not very deep content in this class. But I would still expect that you will probably need about 5 to 6 hours every week of study time beyond the classroom, every week. Okay. If you are, so it might be reading the notebook, reading the textbook, reviewing lecture notes, and then doing homework. If your workload is kind of getting more than that, if you're spending more than 6 hours and maybe you're not seeing results, or even if you're seeing results, but if you're having to put more than 6 hours, let's talk during office hours, right? So I want to make sure that, you're studying right, you're appropriately, doing the thing. But 6 hours should be more than sufficient for studying outside of the class for this class. Okay. All right. As I said, that none of the tests are cumulative, but then there would be a cumulative final that's going to be optional. There will be a plus or minus grading. And the way the grading works, sometimes folks find themselves disappointed with the grade that they receive in my class. So I have two sort of things to say about that. First thing is, even though at this point the grade might seem the most important thing for you guys, but I can tell you from experience, my own experience, and then experience of 17 years of teaching and talking to students who graduated. In fact, the grade is not the biggest thing that you get out of this class. What you get out of this class is the first thing. One thing is that first thing is the content that you're going to learn. And second thing is, even more important than that, is the practice that you're going to get, to learn new things, training your brain to learn new things. That's the most important thing, because as I said, right, even the textbook that was written like maybe 5, 6, 7, 8 years ago, we don't use material from that textbook anymore because the highway capacity manual just got updated, right? So you may, you will, I can almost guarantee that even if you go into transportation practice, you're not going to apply the exact same thing that I'm going to teach you in the class, right? So it's not going to be precisely the same exact thing. It will, in fact, be slightly related, or it could be completely different. But the real purpose of the class and or of a challenging class is to make sure that the student's brain is ready to handle and ready to learn new material, right? So you're giving, basically, you're learning how you learn, so that when you go into a practice of transportation engineering, when you're out working as a consultant or as a public agency employee, you know how to approach a problem. You are aware of, how your brain learns new things. So if you need to develop a new skill, you have some practice of doing so in the past from school, and you can use those skills to an ability to learn, to learn new things, right? So that's the most important thing, which is why I say that I'll use a plus minus grading, and the grades are not very important, in fact, in the scheme of things. So whether you end up with a B plus or a B minus, whether you end up with an A minus or a B, those things do not matter if you have put in the work to learn the material. If you're able to put in the work and learn the material, even though the grade will probably reflect that, but if for whatever reason they don't, I wouldn't, worry about it so much that I'm losing sleep or something, right? No, I don't think you need to do that. So grade is actually not that important in the scheme of things. You may think it is because that's what you're striving towards. That's what we focus so much on. But the most important thing is the ability to learn, and not necessarily just scoring high grade. Sometimes they're correlated, but sometimes when they're not, it may feel disappointing. But don't be disappointed. If you put in the work, you learn the material, you will be in good shape, I guarantee. I will not be, I value your privacy, so I'll not be kind of publicly having your grade sort of for everybody. So you'll always see my work. Nobody will be able to know what your grade you secured. In fact, I don't even write the final, like every test, that the total that you get. I don't write on the top. You'll just see some points subtracted in your answer sheet, and those points subtracted will then be, sort of, you can add those up and figure out what your total is, and I'll be posting the total directly on Canvas. As I said before, email is the best way to reach me. And then we talked about the travel. Obviously, I'm traveling this week, so I'm out. But I'll be back next week, and I don't anticipate any other travel this year or this quarter, so we should be in good shape there. But if you have, anything, any question that comes up during travel, just shoot me an email. Okay. The last thing, and this is related to grading again, cheating. It's a privilege to attend this university. We do not tolerate academic cheating or plagiarism of any form. And again, it's very counterproductive because, as I told you, right, as I said, sometimes the ability to learn is the most important thing. And if you're copying somebody else's work, first, you can get caught somewhat easily. And second thing is, you're losing out on what the purpose of this class is. The purpose of the class is not to get high grade. And sometimes I know students get caught up in that, because maybe something came up and you didn't do work on the homework until last minute. So if that happens, just reach out to me, see if I can extend the deadline. Sometimes I can, sometimes I cannot, but sometimes I can. Because what happens, you might still take a grade penalty on that a little bit, but it's more important to putting in the time. To put in the time is the most important thing. So make sure you're able to do that. And yeah, just ask me for an extension. I'm most of the time I'm happy to provide it if I can. Sometimes what's hard for me is to provide extension for homework number 3 or the problem set number 3 for the module 3 problem set, because I need to grade it, because you might be taking the test based on that same midterm, and I need to provide you with the solutions right away. So homework number 3 might be the hardest one for me to provide solutions because I might be in a situation where I need to give the test right away, right after that, or the next day even sometimes. And I want to make sure that I can post the solution. So I may not be able to extend that one. But it's possible that you could just, yeah, because the most important thing is for you to put in the time and effort to learn stuff. And that's what I'm going to incentivize. So always reach out if you're running into something. Don't try to, take somebody else's work and copy it. And then late work and absences, yeah, it will, if you submit something late, you will lose some credit. But again, losing credit is not as important as having the time that you put into to your work. Make sure you turn your cell phone off and or in silent mode. Unless you're taking a survey in the class, you should just keep it on. If you have the phones going off all the time, that would be a problem for your participation grade. But I haven't seen that happen in a long time anymore. So that's good. Okay, so that's the discussion of the syllabus. Any questions about this? Any questions about the class? Oh, so there's something on the chat. Yeah, we'll talk about Thursday in just 1 second. Okay, I guess. So the only question is like, are we meeting Thursday on Zoom as well? We may not actually be meeting on Thursday. Let me see how I do with chapter 1 first. If you're able to wrap up chapter 1, we'll just meet next week when hopefully everybody has Canvas access and I'm back in person class. And then by that time, I'll just have a very short assignment for you. And then that assignment you can do in due time. You don't have to do it this week, but I will just post it and make sure that you're working on it. But I'll have some reading assignments for you as well. But again, those reading assignments won't be due until next week, partly because I cannot provide the textbook access to everybody who's not enrolled in the class. Okay. Okay. All right. So this is 321. Again, this is your textbook, a PDF file for your textbook. You can download it if you're already there. But I want to get started on chapter 1, which is sort of the introduction to transportation engineering class. So just so this is chapter 1 of your textbook. And it's a short set of slides. So we may be able to get through this rather quickly. Again, this is from CE 321 chapter. You can still see the slides, right? Everybody can still see the slides? Yes or no? Just give me, some of you can give me a thumbs up. Everybody can see the slide? Yep. Okay, perfect. Great. Thank you. I have my confirmation. So I want to just specify the learning objectives again, define transportation engineering, identify the legs of transportation system, ask the questions necessary to specify the system, and provide examples of performance measures, right? So those are your sort of 4 learning objectives for this class. So transportation basics. And in your lecture notes, you'll always see something like this, right? You'll always see either here with the title slide or title heading, or within the discussion that I'm having within some bullet points, you'll see these section numbers 1.1.1, 1.1.2, and so forth. And what they are the sections of the textbook where you can read more about that. And if you ever see a section, that is the reading assignment. That is basically a reading assignment. So anytime we're going through a PowerPoint slide and you see these section numbers, so that's what I want you to read. Now, reading these sections is important because what I've noticed is that in the first test of the course, first test when the students take, the difference between somebody scoring like maybe a 75 to 80 score versus 90 to a 92 score, what I've seen, the big difference is that whether or not they did the reading assignment. Because from the reading assignment, I ask you some objective answer type questions, some true or false, or some short answer type questions. And if you've done the reading, then you're really successful on that. And for the numerical stuff, I don't see a big difference. Most of you get that right. But in some cases, I see a big difference between whether or not students did the reading assignment. So for the short answer and true or false type questions or multiple choice questions, I see a big difference because the students who have not done the reading of these sections that I specify in the slides, they do miss out on those grades. So make sure that you do that. Okay, so let me try and define the transportation engineering. So goal of transportation engineering is to have safe and efficient movement of people and goods. And safe and efficiency, both of our goals, right? So we want safety and we want efficiency. Sometimes those goals are in conflict with each other. And if they are, like we should be, we should be going after safety. We should be prioritizing safety if that is the case. If that is ever the case that we are interested in safety and efficiency as two twin goals that have some trade-offs involved, we want to, maybe trade off efficiency for more safety, right? So safety is a priority number one. But again, we don't force cars to drive at 5 miles per hour, because if they did, probably nobody will die on the road. But we wouldn't design freeways that only take people 5 miles an hour, right? So we want to have some sort of efficiency. We want to make sure that people can get where they're trying to get in a safe manner. And to do that, we let people drive, and it's efficient as well, right? So safety and efficiency are twin goals, and we want to achieve both. But sometimes when they're in big conflict, we want to prioritize safety, but we don't always do that, right? So in practice, sometimes you'll see, people sacrificing safety for efficiency. So for example, in my opinion, you want to probably have slower speed in downtowns, right? Downtown, because there might be a lot of pedestrians. And as the speed increases, pedestrians are at an increased risk of dying from collisions. So if you want to really prioritize safety, we would probably reduce the speed so much on city streets and not so much on freeways. We let the freeways be whatever, 70, 75, 80 miles an hour, whatever. But then when you're coming to the city streets on dense urban areas, you want to make sure that the speed limit is lower and lower and lower. But again, you can't go too much lower because again, people, if it were up to me, yeah, you would want to reduce the speed so that, the cars are not going, pretty much going the speed of a reasonably fast bicyclist, right? So if they can do that, they will save a lot of lives. But again, we don't always prioritize safety, even though we should in general. And when we talk about movement of people and goods, in this class, we'll focus more on the movement of people. We're not going to talk as much about goods like freight. But remember, this is becoming a big part of transportation system, because a lot of people are foregoing shopping trips because they're getting deliveries at home. And it's becoming a big part of the transportation ecosystem. And we want to make sure that you're aware of it, even though we don't cover that in depth in this class. We apply physical sciences, that's your physics, your math. And then we apply social sciences as well, because as I said, there is a lot of human factor stuff that depends on psychology, for example. And there is a lot of, so social studies that come into play, right? Because we are actually, and there is the transportation decisions are very political in nature. So there's political science in there too. Funding decisions could be very political, for example. So this makes transportation engineering a little bit different from geotechnical or structural engineering, for example, because in transportation engineering, the application of these social sciences is already built in. You have to consider those to become a successful transportation engineer. And now, that may be something that you find desirable, but more often than not, I've seen like students don't find it desirable because they don't want anything to do with social science. But again, in this class, we're probably not going to dig too deep into these social sciences. However, and then we'll not ignore it completely. We will dig some into human behavior and I'll point that out as we go through the material in this class. But as you kind of move towards tech electives, higher level classes, and you go into practice, you'll realize how important the stuff about social science turns out to be in the practice of transportation engineering, which makes it very, very challenging. But again, transportation is different in that, like, if you look at all the other disciplines within civil engineering, the balance of the knowledge that you need of the physical versus social sciences, it's very tipped towards physical sciences. But in transportation, we're much more balanced. We need the knowledge of both to be a successful professional in this area. And again, that may or may not be, your cup of tea, which is perfectly fine and reasonable, but something for you to think about. And then demand for transportation is considered derived demand. And derived demand, the meaning is that, a lot of the travel, almost all of the travel, is because we want to travel to get somewhere. We don't travel for the sake of traveling. We travel because we want to get somewhere, either for work or for pleasure, for meeting somebody, whatever. Could be any reason, So that's why the transportation demand is not sort of an organic demand. It depends on where people may be interested in going. So, for example, San Luis Obispo has a big university campus like Cal Poly, right? And there are 20,000 students, there are 5,000 faculty and staff, and they need to get to San Luis. So the demand on 101 freeway is not because people love to be on 101 driving along. And that's not within the city of San Luis Obispo. That's not even a very pleasant stretch to drive on. It's not a coastal view highway or anything like that. It's just an inland highway with a lot of ramps, with feeding a lot of traffic. But there is demand, right? But so people are not there to just be on Highway 101. They're there because they need to get to Cal Poly for their work or for studying and whatnot. So that's why all the demand for transportation, unless you're talking about some specific scenic roadways where people want to be and drive around, most of the travel demand is considered derived demand. And that becomes important because, again, you need to know the travel patterns of people, behavior of people, to be able to derive how many people are going to use a particular segment of the highway. Whether or not people want to minimize their travel time, or do they have other motives? Do they have other trips? So that's why demand for transportation is derived demand. And to address and figure out that demand, we don't only need some mathematical approaches from hard sciences, we also need to study the behavior, which comes from more soft science. Okay, so this is sort of your definition of transportation engineering. Understanding of the transportation system require sort of three major areas: the components, the leg, the activities involved in putting the system in place, and leg three, issues that may not be included in the decision-making process affected by the decision. So let me first pause and talk a little bit ask you about is the definition of transportation engineering and how it may be a little bit different than other subject areas within civil engineering. Any questions on that? And I'll just maybe take a little pause, give you opportunity to ask questions. Okay. I haven't seen any questions in chat, or I haven't heard anything, so I'm hoping that you got the idea at least. Okay. So talking about these three legs, the components, can you put into chat for me? What do you think I mean by components here? What are the components of the transportation system? Love to hear something from you in chat. Anybody? And again, if you don't feel like sharing with the whole class, you can just direct message me. That's perfectly fine. Or you can put it in the chat for class to see. That's fine. I'm just looking for a few responses. Would love to see. Again, participation is important, folks. Yeah, vehicle, users, roads, infrastructure, all of these things are the components. That's exactly right. And again, because human beings are a big component of transportation as road users, there are always problems, right? There are always thinking and maybe sometimes not thinking and so forth. So very important component there. Okay, that's great. So you guys got by and large got an idea about what components are the vehicles, the users, the infrastructure, all of those things are component. Leg 2 is what this class is about. Activities involved in putting the system in place. Right? So this is design, this is operations analysis to put the system in place. So this whole class is about leg 2. What kind of activities? How do we learn about these activities that we want to take on to study and put together that system? And then leg 3 is also interesting and important because when we are doing leg 2 activities and putting together the system, we might not be, issues. There could be issues that may not be included in the decision-making process, but might be affected by that decision. So for example, when we built the interstate highway system, when we built most of the infrastructure in this country, the roadway infrastructure, we did not account for the people who may be physically challenged or physically disabled, right? But obviously, the demand for transportation from those folks got a severe impact. So even today, even after 20, 30 years, 35 years after the American Disabilities Act was signed and enshrined into law at the federal level, even today, you see the impact of, because what we did not do at that time by incorporating handicapped persons, travel needs into our system, you still see that the demand for travel by handicapped people is much lower. There is that unmet demand. Their trip-making abilities are still severely hampered. And that's what you see, that even if you control for whether they're working or not, because a lot of disabled individuals are not able to work, and even if you take only the people who are working, so control for the employment situation of able-bodied person versus a disabled person, you find that the disabled person travel or make much fewer trips. So that's your leg 3 right there. That it's an issue that you did not include in the decision-making process, but it had a severe impact on that. And that's kind of what I'm asking under which leg would you think accessibility falls under? So for the longest time, and even in some cases currently, you could argue that it falls under leg 3. But what's happening is right now is that we're trying to incorporate that information into leg 2 now, right? We're trying to do something where we are saying, no, we cannot have this happen. So I'm encouraged to see that a lot of these, automated shuttle companies, they are trying to do the right thing from the beginning. They're making sure that whatever vehicle design they create, whatever infrastructure they co-build with the agencies for connected to an autonomous vehicle and automated shuttles and so forth, that infrastructure is in fact handicapped person friendly. And that's good that, things that used to be leg 2 are now moving into leg 3. And same thing about safety. In terms of safety, we will always just go by the design standards. And if we design everything to design standards, we thought everything is safe. But obviously that's not the case, right? Because everything in the US is built to design standards. You'll be hard pressed to find something that violates AASHTO's minimum require AASHTO Green Book, the design guiding documents, or California Highway Design Manual. There is pretty much no infrastructure in the state or the country that does not adhere to the design standards specified by the relevant design guidelines, right? But crashes do occur. So again, your activities to put in the system in place, the activity was based on design, based on the AASHTO Green Book or California Highway Design Manual, and we did that as practitioners. But crashes do happen. So safety is a leg 3 situation, which it should not be, but it is. But with highway safety manual, now we are able to estimate how many crashes should you expect on a particular road. And at the beginning, at the outset, try to minimize that when you're building the infrastructure. So again, safety is the same way. It used to be a leg 3 activity, We'll just design everything with standards and then hope for the best. Hope no crashes happen. But crashes did happen. They still happen. Almost 40,000 people die on US roadways every year, which is a tragic number. And, uh, you know, and we are now at least starting to change where we're saying, okay, no, safety has to also be a leg too, where we need to anticipate. And that's where the highway safety manual comes in. And again, if you're more interested in safety, you should take CE 526, which is again offered in the winter quarter, but deals a lot with different types of safety analysis. So safety again used to be a leg 2 issue, sorry, leg 3 issue, and now number of crashes also starting to become a leg 2 issue. So we're trying to estimate that number right off the bat. Okay. Transportation system analysis is a way to design and modify the system to meet the need of end users. We always have to keep the end users in mind. Always, always, always. So for that, when we are trying to meet the need of end users, we have to look at feasibility, whether or not physically you can build that infrastructure. You have the final, and then we have to look at the cost. Do we have the resources to actually build that infrastructure? And if not, then where do we get that resources? What are the costs that we need to cover? Last but not the least, we always have to analyze alternatives. We cannot just come up with like, okay, this is how we're going to solve the problem. Maybe there is alternative ways. Maybe there is doing nothing is one of the alternatives. And then maybe you can build a bridge or whatever infrastructure you need in multiple different ways or through multiple different alignments. You could lay out the bridge in one location, or you can lay it out in another location. Where are you going to lay it out? Which location is most beneficial? Which location gives us most bang for our buck, right? So we need to kind of look at trying to meet the need of end users, but look at feasibility, look at cost, look at different alternatives that can meet that need, and then pick the very best one. Yeah. So the next one is okay, before I go to the next one, let me go ahead and pause here and ask you, are there any questions? So far, whatever we've talked about, are there any questions about that? Again, you can ask the question in chat, or you can ask the question by just unmuting yourself. Okay, so I'm not seeing any questions. That's great. Okay, so the next thing I want to talk about is like when you're trying to specify the system, what questions you need to ask. The first question you need to ask is, what is the purpose of this system? What is the need that this system is trying to serve? Right? For example, you'll hear a lot about, if you're paying attention to transportation issues, a big hot topic right now in the news. Okay, let me pause here. Let me ask you, have you been like, maybe if you follow news at all, what transportation topic is in the news right now?
What, the planes are crashing?
Yeah, the plane crashes, obviously, somehow the plane crashes have increased somehow. That's a very good point, right? And again, plane collision is a very, very big deal, right? I mean, it's so rare, right? The electric vehicles, they're in the mix. You can't park 20 feet from an intersection, so those daylighting of the intersection, that's in the news for sure. High-speed rail, obviously, always a big topic of discussion, and because it's we haven't built that infrastructure, and can be very frustrating in some ways how long it takes in this country to build infrastructure. And because we have so many veto points, because so many people can get like redress for their grievances, and which is good in some ways, right? The bicycles, they're always in the news. I'm more interested in what you may have heard from the national media the most Uh, and those are some excellent topics, right? That folks have written out. Uh, that you cannot park 20 feet from the intersection, the bicycles. Uh, there's one that I'm specifically interested that I'm hoping that I would have heard about, and this is related to where the media is located, right? So, you know, what is the hub of the national media, right? Where is the national media uh, always, you know, where most of the journalists are, right? Most of the national level journalists, you know where they are, right? They're in DC or New York area. Have you heard anything from New York recently? Anything from New York? Yeah, the congestion prices. Yep. So that's kind of what I was getting at. Sorry, I had to sort of force you into that discussion, and all of these can be interesting topics as well. It's just that what was in my mind about congestion lane, right? So you have to think about if people are going to have so congestion pricing system is a system. You're putting together a new sort of uh, system in place for charging people toll for coming into the city, right? And it's a very politically hot topic. So that tells you like why social science is so important, right? I mean, you look at that opposition and you think like, okay, maybe, if this happened before the election, this will have certain implications, right? They already, in New York, maybe obviously New York's, I mean, the federal election probably won't get impacted, but definitely local and state level elections or even the congressional level elections would have mattered because when they decided to put it in. And congestion pricing, like what's the purpose of that system? The purpose is to reduce the delays, maybe collect revenues, but that's a secondary purpose. It should not be. But congestion pricing is there. The purpose is to properly account for the externalities that you are causing. And the idea of externalities in economics is that, you know, when you're using the system, right? The cars, when they use the system, cars actually don't damage the pavement, right? So we know that it's the big trucks that damage the pavement. It's not passenger cars, and you will learn about that in the pavement module of this class. The idea is that we don't, but the purpose of that system is the cars do cause congestion a lot, right? They do cause a lot of congestion, and each additional car that gets added to the mix, it causes more and more congestion. And what you learn is in the class is that when you have very few cars, you can add more cars without any additional congestion. But if you are at peak capacity, even adding one, two, three, four, very few cars can bring your system to gridlock. That's just how the transportation works. So the purpose of the system is to minimize congestion by charging the price to properly account for the additional cost that you're bringing to the system, right? What's the area of coverage? Where do you have the worst congestion, right? So that you could charge the toll in those locations. What are the technical specifications? So technical specification would you have a completely dynamic toll that varies by time of day? Maybe you don't need to charge that toll in the nighttime, right? Because nighttime there is no congestion. I mean, I don't know about Manhattan specifically, right? So maybe Manhattan is something that's even more congested even in nighttime, right? But so we can figure that out. But the technical specifications would be whether you want to charge the same dollar amount every week or every day, at different times of day, or you charge based on how much is the demand. Uh, you know, what's the capacity? Can you reliably charge people, right? Whether it's cost effectiveness is like, is the enforcement of these rules of congestion pricing, because you're going to charge the toll using, using license plates. If people start to mess around with the license plate, then, is it cost effective? You'll have to enforce those rules. Is it going to be cost effective? So when you put in the system in place, you have to ask these questions. And same thing, you could talk about the high-speed rail, right? You could go through these questions, come up with some answers before you can start putting the system together in place. But these are some of the questions that we need to ask anytime we're trying to build or create a new transportation system solution. Okay. And again, this topic number 1.3.2. So that's what you're going to refer to in your textbook so that you can read about it and make sure that you're on top of that reading assignment. Okay, last slide. So then last thing I want to talk about is performance measures. These performance measures, again, they depend on the type of system you have. Average speed could be a performance measure. If you have, if you have a transit system, its range could be a performance measure. The cost of operation, how much does it cost to run the whole system? Reliability. So for airlines, it feels like a lot of folks are interested in airline operations. So reliability, obviously, a collision, airplane crash is a big failure. So failures per unit time, failures per unit takeoff, for example, that would be a good reliability measure. Those numbers are fairly low, but again, because they are so severe, we cannot tolerate that failure. Airlines, they do something very funny with their scheduled flight times. They will technically um, they will mark their sort of scheduled time to be a little bit longer than what it actually takes to get from point A to point B, because so that they can make sure that their online performance is pretty good. So most flights, if everything goes fine, most flights tend to land early. Or at least the flying time is lower than what they communicate to you, because they get delayed taking off and landing sometimes in taxiing and so forth. But if you count just the flying time, that typically is lower than what you would see between the difference between takeoff time and landing time, right? So because they want to account for that, they want to have a higher reliability, higher on-time performance, and so forth. And you can read about more about performance measures depending on the system. So again, these performance measures clearly depend on what type of system you're talking about. If you're talking about the freeways or intersections for cars, then vehicular delay would be your performance measure. For pedestrians, it might be how many pedestrian collisions per year. It could be, if the pedestrians can arrive from point A to point B at their possible highest possible speed. Their average speed of pedestrians could be another performance measure. So just is context dependent, and it's dependent on the mode. But you can read more about them in section 1.4.3. As I said, anytime I point out these section numbers, that's your reading assignment for the class. All right, so that basically concludes our chapter 1. If you have any questions, feel free to reach out. You can ask these questions right now as well. If you're looking for a permission number, you can send me an email, and I'll make sure that you get one. If you don't get one by Monday, remind me again, and I'll make sure that you get one, because I'm going to be arriving on Friday, and Friday is when the permission numbers become available to me. Okay. Any questions? Okay, so it looks like we did get through the whole class. So I'll just make sure that there is no class either on Zoom or in person uh, on Thursday. So there is no class. I think we did a good job of sort of wrapping up the material that I wanted to cover. Oops, sorry, not Jason. I wanted to say to everyone in the meeting. Okay, so there is going to be no class on Thursday. So just make sure that you're up on your reading. And if you're on waiting list, just hold off. Maybe you want to drop the class completely. So I don't know, but just hold off until Friday for you doing your reading assignment. But all the other folks can get started on it. Okay. Are there any questions whatsoever? Okay, I see something in the chat. Okay, thank you. Okay, if there are no questions, you're free to leave. I'll see you guys when I get back, or on Monday office hours. You feel free to stop by on Monday office hours. I'll be there. Or if not, then I'll see you on Tuesday.
So I sorry to